All right. Each talk is 5 minutes. Each speaker has exactly 5 minutes. If they are not finished in 5 minutes, they get gonged off the stage. I've got gong duty while Ethan is speaking, so
Cool.
Go for it.
I haven't done a talk in a while, so I'm going to try and race through this in 5 minutes. Let's get the screen up, please. We good? We're good. Yes, the return of the revenge of the tales of the performance training branch instructions, blah, 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 blah. You can all read that. I have a tale about branch predictors that's going to make you scream. So I've had an incredibly busy year. This has been my side hustle for the last year. I have now become an official part of Doom and Doom 2, specifically my multi-threaded renderer. It is still a pure software renderer. It's also not the first time that software renderer has been released in a commercial product. That would be my last year's side hustle, Rise of the Triad, a game from 1994, which also used John Carmack's rendering code. And just to give you a bit of an idea of what it is, here we go. Ooh, yeah, that looks like a bit of an old school game. So, now we did have a bit of a small problem here, though. See, these flaws here, this is actually not Carmack's original code running. I completely rewrote the flaw renderer for a number of reasons. And we started getting reports from users that the PlayStation 4 was incredibly inconsistent in terms of performance. And I'm like, why would just the PlayStation 4 be a problem? Like, it's basically the same CPU that's in the Xbox One. It shouldn't be a problem. And we can't just ignore the PlayStation 4 as much as we would like to. It's an 11-year-old system that's still used about as much as a PlayStation 5 is today. Look at that graph. That's insane. Nobody's upgrading to the PlayStation 5, basically. So I asked some people. I don't have access to the Sony hardware to profile this because I'm a Microsoft employee. Can somebody please run the profiler over it? And they came back saying that this little function here was taking up all the time in the renderer. And this is basically a little templated function so that I can generate really, really optimized floor rendering for different texture sizes, different functionalities and all that. And it does that by unrolling a loop. And using this little sampler sample here, that's a templated argument, and it'll just go off, 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 off. Unroll the loop. Cool. It didn't make any sense to me as to why this code would be weird. That's the code that gets inlined, right? So I'm just like, okay, I need to see the disassembly of this. And somebody gave me the disassembly, and then I worked out it like PlayStation's a clean compiler, same output on PC, in fact. So if I come over here, stick a little breakpoint in it, go to disassembly, and I'm just thinking, please don't be what I think it is. Please don't be what I think it is. Anything but what I think it is. And then I'm scrolling down, and it's what I think. Hey, what are you doing? Come back. It's exactly what I think it is. Can anybody tell me what looks wrong there? Yeah, compare jump less. Now, just for reference, that's what the code looks like. There shouldn't be a jump in there. I'm like, okay, what is the min function doing? No, that actually looks sensible. It's an inline function. It's a ternary. That should just compile down to a conditional move. Why is it not doing that? I don't know. Maybe it's code generation. It's 2024. Maybe it should be a const expression. Same result. It's still doing the branch. Okay. You know, they've been wanting us to replace defines like that. Still the same. There's no move intrinsic. You know, you've got to completely rely on the compiler to do a move intrinsic like that. So what I had to do, I had to write assembly to make sure that my conditional move got inserted, and then it finally worked as I expected. See, that's the actual code output. That's what I wanted. I had to write assembly for that. Now, that makes me happy. But why is this all relevant? Well, that would be the discussion that Manu started on the forum there. Now, this is a modern branch predictor, and working in the microcontroller space, you're going to work on worse hardware than that. And every single good programming practice you have out there will not survive whatever the compiler outputs, whatever the hardware does. We need ways to control this. So please, by all means, listen to Manu in here, and let's get something moving on this front, because this will be a valuable addition.
So, hi everybody. My name is Eyal. I want to talk about how we use D at Weka. But before that, I want you all to know what Weka is, so I'll start with a small sales pitch. Now, I'm not a sales guy, but I'll give you the elevator pitch. So, as we all know, we're entering the AI era. Whether you want to or not, as a company, you have to invest in AI these days. Now, every data center for AI, but even not for AI, has to have these three basic components: compute, networking, and storage. Now, compute and networking has made huge strides in the last 10 years. Maybe even the last 5 years, you have like 20,000x on compute. On the other hand, storage has kind of been stuck in the past. You have 30-year-old solutions using NFS. They can't saturate the huge networks that we now have, and it's become the bottleneck of many data centers. So here comes Weka to the rescue, and Weka basically brings the storage to the level of compute and networking that we have today. So Weka has a wide variety of customers already. So for example, 23andMe and Genomics England, and I can't expand on a 5-minute mark, but a lot of very interesting use cases. A very large autonomous vehicle manufacturer that, for example, had a machine learning cycle of 1 year reduced to 12 days with Weka. We have generative AI as a very common use case. And one of my favorites is the Vega Sphere. If you've heard of it, it's like a huge theater with the most pixels in the world and the hundreds of thousands of speakers. And the data requirements of this thing made them just impossible to use anything but Weka. Weka is basically the only thing that comes close. And actually, they use Weka to serve this theater. So back to D. Like, how does Weka use D? D is a very versatile language, which fits many, many domains. And we make full use of that because we innovate in many domains. We have our own super efficient network stack. We have our own high-level RPC abstraction. We have data protection and erasure coding, all in D. Everything I'm mentioning is implemented at Weka with D. We have similarity-based data reduction across exabytes of data. It's pretty crazy stuff. We have a distributed consensus algorithms implemented in D, failure-resilient file system with POSIX semantics. We have concurrency primitives, an ecosystem around fibers, scheduling. We have a tracing system that without which we'd be hopeless in debugging our sophisticated solution. It's impossible to debug a complex distributed system without it. And we have this very, very strong performance case, super optimized hot path. We use advanced profiling, and we're basically the leader in data storage in performance. And for that, because we have such high demands, we do have to use the release flag. So what other unique features make it so valuable for Weka? So metaprogramming. D is awesome at it. We use it for our RPC layer. Basically, we just declare functions as regular functions, regular data types, and it works with RPC that's auto-generated. We have automatic upgrade code. I'll expand on that in a bit. We have compile and testing. I'll expand on that as well. We have other languages that want to interface with Weka. We can just generate automatic Python code or Java code or whatever from our data types easily with metaprogramming. And of course, convenience. If we find ourselves writing some boilerplate, which I think in every project do, we can just eliminate it with metaprogramming. Another feature of D is the mix of system and GC. You don't have it in many other languages. And most storage solutions, other companies, they actually use a different language for their called control path, and C or C++ for the hot path. And this language barrier is very difficult and costly. But in D, we can use D for both, because we have the hot path, no GC for the data path, and we have the GC part where it can be slightly less performant for the control path. And of course, the integration is seamless, and the entire code base is available to both our control and data path systems. So let's dive into some examples. Let's imagine this unit test. This unit test might require compiling and linking quite a large subsystem before we can actually run it. That makes our dev cycle, edit, build, and test, very long and annoying. But see the very subtle difference. Unit test became UT ! And now it runs at compile time. And we can just do a very short -o- compilation of our module and get the unit test running as part of that. It's amazing. Automatic upgrade and downgrade. Imagine you change a struct in a way that breaks upgrade or downgrade. You basically get a compilation error forcing you to put these annotations. And then you get auto-upgrade, auto-downgrade across the boundaries. And whenever you basically rolling upgrade, you have all the new software talking to each other, and it just works. So we are hiring, and I think there's tons of very interesting stuff.
Do this.
Do you have your rough code open source by any chance? Because I would be interested in that.
It's not open source. Right now, Weka has only open sourced one component, the Mecha reactor. It's a very small portion.
No.
Basically, we would love to open source more stuff, but it's an investment to make, and it's easier to do once we see there is interest on the other end.
Hi, everybody. I'm just going to tell you about everything I have been cooking up in dlang for the past year. Well, first of all, the Facebook group has grown. It currently has 615 members. A woman from Kenya, Africa, contacted me on Facebook to ask about dlang. I told her about it, and then she told her classmates at her University, and they started a project. They are creating an operating system written in dlang. The DMD GUI has been improved. Now it has some more options, and it shows error messages here in case you do something wrong. It tells you the error messages. And I don't know about you, but I work with those lithium batteries that you can put together to build packs, so you can make an electric bike or something. And therefore, I have made a battery counter using dlang, so you can add more, so you can keep track of how many of each of them you have in your workshop. You can tally them as well in order to know how many of the oranges you have. And it shows the total right here. The neural network creator has been improved as well. Now it makes sounds too. A software for floating point math, which is hardware independent. It has the functions add or subtract, multiply, divide, power, and root. You write the number as a string. You can set up how many decimal places you want. That way, it is not affected by the loss in precision caused by the hardware, which means it will always give you the same results regardless of on which computer it is running. Oh, and it is very fast. On my old computer, it can do tens of thousands of operations per second. So just a question, why isn't everybody... Thank you. This was the very last slide. Why isn't everybody using dlang for everything?
I like to read, and I don't always read about D, which is unfortunate, but there's not a whole lot to read out there on D yet. So I read other things, and I read a book recently called The End of the World is Just the Beginning. This is a demographic profile. Females on the right, males on the left, youngest at the bottom, oldest at the top. Do you notice something interesting about this chart, though, besides the fact that it's got the China flag on it? There in 1990 and 1970, there are two big areas of people that were born. Okay, great. This is Japan. Uh-oh. Japan is 20 years ahead of where China's going mathematically. Okay, so we've got, 1975 and 1950. Another interesting note about Japan specifically is that block is double the size of their block of their young people. Okay, so what does this have to do with D? Well, programmers are humans, last I checked. Some of you might be LLMs, I don't know. But we need humans to write code. And so, okay, so, I'm working on Asia right now. So why don't we take a look around, somebody from Europe. Uh-oh. Most of Europe also looks like this. You've got a nice large chunk of people who are in that 65, 60, 70 age range, and they're retiring. And the interesting thing about these people is they're the ones who built the world we live in. The internet, cell phones, all of it. And okay, so, well, yeah, by the way, France is the exception to this. I don't have a chart for them, but theirs looks a little better. So we'll go to the United States, because the United States, that's going to save everyone, right? The United States loves to save everyone. Uh-oh, right down here in 2025. The United States is starting to go down the same path as Japan. This is a problem for us. We might be a little later, but we're going to get there. What does this have to do with D? Over the next 25 years, we will probably lose about 3 million programmers, just on the basis of people get old and die. It's a sad fact, but that's what's coming to the world. So any language that requires high numbers of these highly educated humans is going to become very costly to use. And yes, I am looking at you, Rust, because as much as we all love to rag on Rust here, it's a very complex language that requires, well, higher IQ than I am. And I mean, there's people in here who could do it, but, I'm not one of them. But also C++ kind of fits into this basket too. C++ just requires a large number of bodies thrown at the problem to be able to solve even a smaller problem. The universal case for D is that in a world where programmers are an increasingly scarce resource, programmer efficiency is going to become the driving factor that determines how we pick the languages that we use. And D is multi-paradigm, memory-safe, systems programming language that is programmer time efficient. And that's my lightning talk. Sorry, Ethan.
Don't leave the slot unfilled.
So you said we're going to lose 3 million programmers. How big is the population at the moment?
For programmers?
Yeah.
27.3 million.
So more than 10%. Yeah.
Yeah, it's about 12.5, 13%.
2 years ago, I did a talk about structured concurrency, and I want to give a little update. Now, a lot of things have happened in 2 years, but I haven't been working on this all that much. But anyway, some things have happened. A quick refresher. The aim is to get any concurrent or parallel work to be encapsulated by whoever starts it or owns it, so that it's a lot more easier to reason about things. Any errors that might pop up, there's someone to send it to, right? If you need to cancel something, there's always a parent that can kind of handle that stuff. So it makes it a lot of more easier to reason about already complex code, right? Because a lot of this concurrency, if you have many things going on, it's going to be complex enough, hence that. A little update. One of the goals I had was to kind of clean up and fix up and redesign bits to kind of try to propose it for inclusion into Phobos. But one of the problems I had was I had lots of, well, not lots, but I had a few external dependencies. I dragged in a bunch of code, was unnecessary. So I had to remove those. That turned out to be rather difficult. But with those extra constraints and with those libraries gone, I was kind of forced to redesign things a bit. And it turned out a lot better. So fewer memory allocations. Some of them were just removed. Some of them moved to the stack. And it made things simpler, less moving things, right? And it resulted in performance improvements. There were some issues around the streams concept, mainly around back pressure. So I rewrote them into sequences. Not my idea, but it turned out to be a great one. And they don't have that issue anymore. And after that stuff, I kind of went into the I/O and fibers and that kind of thing. So when using it, we saw that it was safe, performant, composable, and it also integrates correctly. So if you have some existing asynchronous code, we've always found a way to kind of wrap that or include that. And I think that's because the sender-receiver model captures the underlying essence of an asynchronous computation so well that it just fits with a bunch of other stuff correctly. But it's not all great. It can be very daunting to write sender-receiver code. You're going to have to learn some new things. Some things that you already know might not work. So you're forced to kind of reshape your code in a way that you might not want it. And that's difficult. But what if we can give up a little bit of the performance, maybe allow some allocations, maybe some indirections, maybe some type erasure? Then what's the next best thing that we can do? Fibers. The fiber here that you see and the yields, those actually operate on senders receivers. And with fibers, you can just program synchronously. You don't have to learn any new things. You use force and this and that. By the way, the code here is just, I shrunk it down. It's don't write it like this, but you get the point. Because you can use them interchangeably, you can do half of your work here, half of your work there. You have a choice, which means that you can pick one approach and then later on decide, hey, I'm going to refactor this and get it all going. By the way, all the algorithms, all the sender algorithms, they work on all of that too, right? So you can start it one way and then slowly fix it others. Fibers, really? I don't like fibers. They have a few core issues with them, but it is the best that we got. So that's what we have to do with. I am sure that if we get something else, let's say stackless coroutines maybe, then we will be able to integrate them the same way and get like the same kind of trade-offs. So that way you have a choice. You can write things like you want to, and then refactor if you need to, kind of mix and match things, and everything is just going to work. Done.
Not really a question, but I just want to say that the .yield calls looked a lot like .await calls or like await in JavaScript.
Yes.
So I just want to say experiment with that concept and premises, and I think you're on the right track.
Cool. Thank you.
Okay, yeah. So those of you who remember from last year, you kind of generally know the score. So 5 minutes of pain, and then it'll all be over, and we'll be on to the D again. Okay. So when I first heard about lightning talks, I thought it was a bunch of people standing up on stage for 5 minutes bitching about Apple charging cables. If I fork the Wikipedia page on Yak and create my own list, does that make me yet another compiler? If a self-driving car goes from London to Paris to Berlin and back to London and nobody notices there's a driver, does it mean it's passed the Turing test? I've always thought the song When I'm 64 should have been sung by the Commodores. More technical stuff. Okay, if I take 8 drill bits and I put them in a box, does that become a drill byte? When people first learn C++, they sometimes ask, what's the difference between char and wchar-t? And I say it's really easy. Char is for narrow characters like an I or a 1 or et or L. And wchar-t is for wide characters like a W or an M. Simple. I thought I'd get back into C++. I thought I'd do some intensive training on undefined behavior. It was a crash course. I've also started working on my own concurrency primitive. If the thread enters and there's already one there, it basically just terminates it. I call it a hemlock. I've never understood why people overload the plus operator for string concatenation. I mean, it just doesn't add up. The longest programming book I ever took to read was one called Algorithmic Complexity by somebody called Owen Squared. I think functional programmers are all arsonists. They spend all their time playing with matches. Yeah, I had a friend who started drinking and smoking and basically staying out heavily and decided to get out of web development in Ruby. I think he's gone off the rails. But it's okay, he decided to become a property developer. So he spends all day writing getters and setters. Is a polyglot somebody who boasts about how many programming languages they know? Wrong audience. I once wrote a bash script with just a hash and an exclamation mark. That was it, the whole shebang. There's a maximum rate that you can write characters to a console window known as terminal velocity. I recently met this guy who described himself as a prompt engineer, but apparently just spent all day playing with ChatGPT trying to tweak his PS1 bash variable. I always struggle to create digital certificates. In fact, every time I try, I just make a hash of it. Somebody in InfoSec came over to us and said, do you do key rotation? I said, yeah, every 3 months we run it through ROT13. I once had to configure a VPN over a new fiber optic network, but I had to give up when there was no light at the end of the tunnel. Upper management said that we were losing market share and we needed to be more disruptive. So I dropped the production database and deleted all the source code. Our enterprise architect is a big fan of object orientation. If you try to use F#, he objects. If you use Haskell, he objects. We once hired this guy, this DBA called Sisyphus, but he was rubbish. Every change he made got rolled back. People who joined Twitter after the 23rd of July 2023, known as Generation X. The other day, my timeline was full of tweets from John Carmack and John Romero about the state of the games industry. I felt like I was doom scrolling. Is that it? I've got time left.
You got 20 seconds.
Oh, okay, I'll do one more. Okay. If I write a for next loop in BASIC and I put loads of comments in between it, would that be REM sleep? There you go. I feel the pain.
On me?
Yeah.
Yeah, go on. We are not taking questions for that talk.
All right, so this is like the director's cut of my talk. As I alluded to in my answer to Timon's question, I had a whole chapter on the DIP 1000 limitations that I scrapped, so here is some of it. So we're in a situation where we want a safe language, a simple language with simple pointers, and use stack memory, and we can only pick 2. So currently we have simple stack memory, pointers are simple, and we can use stack memory, but there's this glaring hole in safe where you can return a local static array. So with DIP 1000, we added scope checks, so now it's safe and caught, but it gets scope pointers, complex, some people don't like it. And there's been the alternative where it's simple and safe, but there's no stack pointers, which is Robert's idea. So you don't accidentally have to deal with scope pointers, you're just straight up told, nope, it ends here. So we're not really sure yet what the next direction is going to be with additions. Currently, DIP 1000 is in the preview flag. And the idea was first to make it a default, but maybe in the next edition, we're actually going to do Robert's safety, and we'll see what happens with DIP 1000. I, of course, want to keep DIP 1000. I think there are some value there, but there are some issues. So last year, I presented them. This is the basic idea. Yeah, the 3 primitives, taking the address, just returning value or dereferencing it and not escaping it. So some issues I presented last year was the implementation at code duplication. These two functions are supposed to do the same thing. I refactored them out in this PR. Since then, I've also refactored escape.d this year. So the number of if statements went down from 310 to 240, and also fixed some latent bugs in the process, which is nice. It can still be reduced a lot further. And this refactoring does allow more new features, new bug fixes, because currently it was such a tangle that it was hard to improve. Last year, I presented this limitation with nested functions. This particular case has been fixed, but there's still lots of other ones. So you're not safe when you're using closing over scope variables in nested functions. Scope inference is still killed by assignments. That PR still is in limbo, but we have ref variables now, and those don't kill assignments, so you can use that. By the way, that also fixed an old issue where std.array, while duplicating a stack array, would pretend it's still scope, but now it doesn't anymore. So that's a slight improvement, but other than that, there's still fixes necessary. People complain about the scope annotations, and I always said you shouldn't write them most of the time. It should be opt-in. Paul Beckett has been working on a dip about inference on default, but in the meantime, I think it would also be great if we could apply auto just to a scope. Currently, it says, oh, you can't have both auto and in the return type, but maybe if you allow this could allow you to write less scope annotations. We want partial and transitive scope. I tried the arena approach on my C2D program, and it has a big context struct with, for example, a symbol table and a source. And you cannot say, oh, the source is scope, but the symbol table is GC allocated. Or you cannot arena allocate the hash map because the keys and the declarations are the reference level deeper, so scope doesn't apply to them. So maybe better inference could help, but it also raises the question, what syntax is gonna say, oh, this field is scope, this isn't? Can we explicitly write that if we need to? So that's still an open question. Ricky has been working on a new proposal with more complex syntax. It's a bit longer, but it is more explicit and allows you more detailed descriptions of things. So that's worth checking out. And yeah, last is a call to action. Share your opinion. Ricky has made a survey where you can kind of give your opinions on what kind of, how much complexity versus how much expressiveness and safety and stuff you want. So yeah, do fill that out. You can find the link there. You can find it also on my GitHub Korpel DConf repo. And there's this thread for more qualitative analysis. If you have specific issues that we haven't encountered yet, share your DIP 1000 woes, and we can take that into consideration as well. And that's it.
I appreciate your work and your posts on this topic. But I did note that you said, okay, DIP 1000 is simple, and then you gave like 3 pages of tables explaining why it's simple.
I think the primitives are simple, but you need to know the existing features of static arrays versus dynamic arrays and ref parameters of struct this parameter and the class. Like it's the existing language which makes the primitives more complex.
Yeah, the actual question, as opposed to me trying to be cute, is, are there qualitative differences in terms of what can be covered by the different systems? My impression was that Ricky's system had the possibility of getting its arms fully around the problem, whereas there were some difficulties with getting, really solving it with DIP 1000. Is that accurate or not? I haven't gotten into it.
Sorry, what do you mean with the last part?
Basically, are there cases which Ricky's system will handle the DIP 1000?
Ricky's specific case is for multiple outputs because it currently return is only for returning, but sometimes you return it by an out parameter. And currently there's one special case where you can return by assigning to the first parameter, but not the last parameter.
Right.
So Ricky's proposal primarily gives more accurate information on which parameter ends up in which parameter or return channel or global variable.
It's a fully enumerated graph. Yeah, okay, got it.
It's more detailed on the assignments.
All right, so I just wanted to show if everyone remembers the little demo of the heap that I wrote yesterday. I showed yesterday. That was all written in D. I wrote it in about an hour while we were waiting for the talk to start. So I just wanted to show you how easy it is to make like a little game-like thing with raylib. I'm going to start from scratch in code D, make a new empty console application. It's going to say select a folder. So I'll just create a new folder here called, come on, Lightning. Open that. And now we get a new D application. Click on that, and now we'll get our dub dependencies in a second here when the thing starts up. We're going to add raylib-d. All right. And the only odd thing we have to do, I'd like to fix this, is we just have to run a little thing that will pull in the libraries. So dub run raylib-d install. And that'll pull in all the libraries here. And it'll also update your JSON file so it adds the proper directives. So now we have a raylib program. And it's as simple as writing a few methods. This is like, when I learned how to do this, I was like, I can't believe this is this easy, and I haven't been doing this for a long time. Okay, set target FPS, 60, while window should close. We're going to begin drawing. Exit and drawing. Oops. And we'll just clear the background first. And let's see what happens now. We should be able to build this and run it. There we go. Oh, I made it white. I wanted to make it black. I'll just switch that real quick. All right. So now let's say we wanted to do something a little interesting. We'll write some text on the screen. Draw text. This loop is going to run every frame. So we target 60 frames a second. So you can do whatever you want in that frame. And 10, 50. Colors dot black. And the font that's going to, or white. We won't see it otherwise. And the font that's going to use is the default raylib font, which looks horrible, but it's nice and already included in the library for you. You can load other fonts though. And I was going to do all this stuff when I was, well, I can at least show how the image is loaded, but I'm going to kind of cheat at the end of this here. So let's say we want to load an image, load texture, and I'm going to use this logo, 512.png. And I'm going to drag this guy into the there. So now we're going to draw that image. Screen height, sorry, width. Minus.
1 minute, no pressure.
That's okay. I'm going to cheat at the end here. I knew I wasn't going to get through this in 5 minutes. And colors, white. The tint just basically can color the thing. So if we do this, we should get a nice thing with the image on the bottom. And then to cheat here, we're just going to load. I did a little animation. So when I basically push the key D, it's going to do a takeoff animation where we rotate and then fly off the top of the screen. I'll just show you how that works. But it's all this stuff is pretty simple. So hit the key D. And there it goes. Thanks. So yeah, if you want to use Raylib library, it's available. I am porting that to D as my talk said last year. So eventually it'll be a little bit easier to start up.
Is it a port or a binding?
That's the binding.
Okay.
Port will eventually be, so you won't have to run that Raylib install. You won't have to install a library. It'll just be all part of it.
We're doing a decentralized database. So what is important when you have a decentralized database and you don't know if you want to store something decentralized, you have to have a same format. We have defined what we call a hash invariant binary object notation. So we have a page for this. This is just a standard, and you can in principle write this in any language. It's inspired by Bason, but in principle, it's much simpler, so you can read about it here. And what we also use it for is hash invariant remote procedure calls, because it's important that we can sign contracts when we send, or messages when we send it back and forth. So we have also a utility, which I'll show a little in a little short. Where is it? Anyway, so we go here. This is an example of how we do it. So we just put up a struct and then just display it, and then this mixin would then make a serializer and deserializer. And I think what is important is that because we use a lot of those objects, it's actually very simple. The only thing we do is we sort the keys in the object so we get the same binary map, so we can make a hash so it's as invariant. So it's in principle very simple, but we found out when we have two different classes. We have an immutable class, which is just a binary, where we have a lazy search on the keys. So when we first have it serialized, it's very efficient. But when we construct it, it's not efficient because we have, or at least less efficient because we have a class for this. So we have a mutable object. So we render this. But in this case here, where we have just a simple struct, we just need to serialize it. So what we do is that we actually make the keys in compile time sorted, so it's already sorted when we had to serialize it. So it makes all those objects very fast. So we don't need to sort, or actually what we had in the runtime is that we have a red-black tree, and it's not very efficient. It also makes a lot of cache misses, but this one is actually very efficient. And what we do is that when we have serialized it, we can also take in a mutable object, instead of just rendering everything, we just put in the immutable object into a mutable object, so we can serialize it together. So we just take the string and then put it into the system. Yeah, so yeah, that's actually it. Then I will just to see if I can find and then we have defined because everybody's using JSON. So also for debugging, it's nice, instead of having just a hex code, we have a utility which can serialize a JSON in a specified format. You can serialize and deserialize it. You can go back and forth because for a lot of applications, it's easier to do this. The type information is also in the JSON, so we can do this back and forth. Yeah, that's it.
I'm presenting the improvements on the LDCLint. This is a project that I started to make last year, and this is basically a plugin for the compiler to run post-semantic analysis in your code. The reason to do this is we don't want to run the scanner after the compilation. We want to run in the compilation phase, so we save some time. So this is some new features that I added from the previous run. One of the things that we don't really want to do when we query the AST of DMD is mutate the AST, because when you query the AST of DMD, you might mutate the AST. So I did a tiny query wrapper of the AST nodes, so I ensure that they are immutable calls. In the case that we can't resolve the calls, I had a resolve wrapper, where if it's resolved, you get the result. If it's not resolved, it says, yeah, it's not yet resolved in this phase. Currently, we only do after the semantic phase, so nothing is supposed to be unresolved, but if it is, we have it. Basically, this is how you have the resolved code. It's a pretty simple thing. And the query, it's a bit longer, but it's basically wraps the AST node, and you can implement some custom methods that use this resolve wrapper. Another thing that I added is the ability to have libd parse nodes alongside with the DMD. It's a good thing that you can port these kind of linting rules. One of the biggest advantages is to have some things that you don't have on the DMD AST with the libd parse, for example, formatting stuff and stuff like, for example, comments that you don't have. So you can have something like override with a visitor, override the DMD AST or the dparse AST. And the visitors, it's basically a wrapper of either of both visitors with a query object. So the query object is always immutable, and you visit with immutable, so you'll never mutate the AST. I also had some other rules. One of them that is in progress is unrolled fortified checks. For example, if you have some parts of the code that you know that it will fail at runtime after the unrolling, so you do some checks there. Another thing that also beat us in Weka is we have, for example, sometimes you have bitwise operations on booleans, and most, like 99% of the time, you don't want to do bitwise operations on booleans. So we have a check for that. Also, another thing is the integer overflow before conversion checks. If you do an operation with a larger and a smaller type, it will convert to the larger type and then it will cast back to the smaller type. So after the conversion, it will overflow and you don't know it. So I created a rule for that. Also, some internal coherence check for the compiler. So basically, I check if anything is unresolved. If yes, I just raise a warning for that. And future implementations is not only running just post-semantic analysis, it's also running pre-semantic analysis. One of the cool things of running pre-semantic analysis is having constants unfolded, because after semantics, the constants are folded. And also more rules to implement. This is how you supposedly define, this is not yet compiling, but I want to compile it soon, trademark. You have metadata of the rule, and you can say, for example, it's the news rule, if it's enabled by default or not, if it runs on HAL modules, like imported modules and also your module, and the priority of the rule. And then you override the visitor and do your check. So yeah, that's it.
Are there already any rules, linting rules related to the use of the standard library? Or places where the standard library maybe is not used but should be used, or maybe even where the standard library ranges are used in a potentially unsafe way?
Yeah, like we can have those rules. Currently, we want to have some rules that is, for example, calls from foes that is known to be error prone. Maybe, I don't know one example, but if you have any example, you can raise an issue there and we can have the rule. Currently, I'm mostly focused on having a good infrastructure for adding rules easily and also interacting with them correctly. So, yeah.
I had an idea, and I don't know if it's a good genius idea or a really stupid idea, and I bounced it off Manu. Went and bounced it off Attila, and they both said I should do a lightning talk about it. So here it is, half formed, and we'll see how things go. There are multiple ways of returning errors from a function. There's error codes, there's throwing an exception, and there's option types. And none of those really seem to appeal to me. And then I remembered something from, long ago when dinosaurs ruled the earth. And I programmed all in assembly language. The convention for signaling an error was to set the carry flag. I thought, wait a minute, why can't we do that with a high-level language? It will work like an option type, except it's really, really cheap. So if your function returns and the carry flag is set, then the value returned is an error code or a pointer or whatever you want it to be. And if the carry flag is clear, then it's a return of some other thing and not returning the error. If the carry flag is set and your code doesn't deal with it, it just returns again, setting the carry flag, and it propagates the error up the stack. You can catch it by having a catch statement or a finally statement. It'll do a jump on carry to the catch or to the finally. And so it kind of works a bit like exception handling, but without all the overhead and all the costs to it. Downside of it is I don't know if any code generators support this kind of programming. I know DMD doesn't. Of course, it could be fixed to do that, but I have no idea what the level of effort in converting GDC or LDC would be. But I think it's an interesting idea. It's very lightweight, very fast. I'm amazed that it isn't already being done somewhere. Somebody mentioned maybe Zig was doing it. I don't know if Zig's doing it or not, but I think it's an idea that we can explore. Maybe we can do something great with it. Well, ARM has flags. As far as I can tell, ARM uses a similar ABI to the x86 where values are returned in registers, not in flags.
When you're starting your function and you're basically like you have all your parameters on the stack, but often at the end of the function, you're basically adjusting the stack pointer. You're having to add to it. Doesn't that set the carry flag and overwrite whatever was set earlier in the function?
Yes, you would have to clear the carry flag at the end if you're not returning an error. So I was thinking maybe, we have extern C and extern D and extern C++ function types. A fourth function type could be the one that has the carry flag.
But I mean, after you set the stack pointer and whatnot, if there was an error, how would you basically set the carry flag?
Throw. You repurpose throw to set the carry flag and return from the function. So, you throw an exception. Well, the exception in D is one word long. You already have the syntax in D to make that work. You have throw, new, exception, whatever. The way that would be implemented in the compiler was it would load that payload into the return register and set the carry flag and then return.
And is the carry flag guaranteed to be stable in the event of you being interrupted? Like, let's suppose there was a context switch and then you resume execution.
Oh, you mean across an interrupt?
Yeah.
Oh, of course. It couldn't work otherwise because lots of use of the carry flag is made in the program between multiple instructions. And if an interrupt between those two instructions changed the carry flag, it would be worthless.
Yeah, it makes sense.
Yeah, we'll try just a quick grok level check on ISAs, and carry flags are prominent in all of them, going back to like even Spark and stuff, but RISC V is not. They might have a little bit of difficulty there. They have a kind of a weird way to express it.
I really know next to nothing about RISC V. So
what would be the real benefit of having this? Because you're not expecting exceptions to happen very often. So you're essentially optimizing a part of the code that doesn't get executed only very few times.
What you're saying is, what is the cost of having this and not using it?
Yeah, maybe.
Yeah. I think the setting and reading the carry flags are really cheap operations. I kind of think a lot of code should be returning errors, and we don't because it's just too clumsy to return errors. Or we return errors using option types and things like that. And when you think about it, isn't it actually costing you even more code to deal with those cases? Like if I do a string search for something and it returns -1 if I didn't find it, isn't that more expensive than returning a carry flag that I didn't find it? You're still going to have to you'll have to do a test and branch after you call the function as opposed to jump on carry. So it may kind of work out that it'd be hard to tell if it worked out cheaper or not overall.
You could eliminate the require to do this stuff probably with something like no throw.
Yeah, no throw.
So then the function can't actually return an error in an error case.
Yeah, we got to cut it there. Yeah, we got to cut it. Thank you, Walter.